given a steel bar and the outside is a copper bar. This is steel and this is copper. Steel bar is of 25 mm dia and the thickness of the copper bar is given as 2.5 mm. Then the outer diameter of the copper bar becomes 30 mm, that is 25 plus 2.5 one side and 2.5 other side, which will be 30 mm outer diameter. In Young's modulus of copper and steel are given, a load P of 100 kilonewtons is applied on the composite section, then P will be equal to load in steel bar plus load carried by copper bar. This is one equation, and the deflection or the elongation in one steel bar will be equal to the compression in the other bar, that is delta will be PL by AE. So P into steel length is same, L length, so into L by area of steel into Young's modulus of steel will be equal to load carried by copper into L by area of copper into Young's modulus of copper. L and L gets cancelled. PS by area of steel will be pi by 4 into 25 mm, so 25 square, into Young's modulus is 2 into 10 power 5, which is equal to copper by, it is pi by 4 into hollow section, so outer diameter square minus the inner diameter square, into Young's modulus is 1.2 into 10 power 5. The pi by 4 and pi by 4 get cancelled. PS, that is load carried by steel, will be equal to 3.7878 into load carried by copper. From substituting this in first equation, P is given as 100 into 10 power 3 in kilonewtons, or we can put it as 100 only. We'll obtain PS and PCU in kilonewton. Solving, we get load in copper as 20.886 kilonewton and load in steel as 79.114 kilonewton. It is required to find stresses. So stress in copper will be equal to load in copper by area of copper, that is 20.886 into 10 power 3 in newtons, by area will be pi by 4 into outer diameter square minus the inner diameter square, which will be equal to 96.7 Newton per mm square. Similarly, the stress in steel will be equal to load carried by steel by area of steel, which is equal to load carried is 79.114 into 10 power 3 by area is pi by 4 into 25 square, which is equal to 161.17 Newton per mm square.